This is Geometry Semester 2. It's the 5th unit called Circle, Angles, Arcs. And it's the 3rd lesson within the 5th unit called Secants Practice. It's on creatormath.com under the Geometry tab. Here are the directions. Copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages. Don't forget that's in a separate file on creatormath.com under the Geometry tab under the table of contents listing for this title. Given the following secants and circle, if A is 100 degrees, B is 50 degrees, what is the measure of the angle C? Hint, they give us the formula already, right? So nothing to memorize here, nothing even to look up. Let's just talk a little bit about some background. So this thing is a circle. The definition of a circle is the set of points equal distance from the point called the center. So if we made points all around this circle, like like the old, if you remember those old dot matrix printers that actually printed by dots, which everything does technically, I guess, print by dots. But these dots add up to a set that make the circle, and as long as they're in equal distance here from the center and you go all the way around, it makes this shape we call the circle. So the circle is not the area in here, the circle is the line. That is the circle. I put my pen right on the circle right there. So notice that we can have a center. From the center to the side is called the radius. From the center to from side across the circle through the center, this is called the diameter. You should know those. Diameter is the longer shape. Come up with a word for D. That's a long word, or a big animal like dinosaur, so it's the longer line. And rat or radius is the smaller line. Some hint to help yourself remember the difference between radius and diameter. They're separated by a factor of 2. 2 times the radius is the diameter, or the diameter divided by 2 is the radius. With that said, there's other segments that we can draw in conjunction with a circle, like a chord. A chord is a line across the circle from the circle to the circle, right? And not passing through the center. So this would be called a chord. It's spelled chord, C-H-O-R-D, but it's pronounced chord. So you just got to get used to that, say it chord. Then there's another type of line here that's like a chord, but notice it keeps going. This line keeps going out to a point, a vertex, an angle, and another one drawn in also touching this same, coming to a point here, or angle. So we form an interior angle here in this thing called angle C. We also have an arc here, B, and we have an arc here, A. Right? So they labeled them A, B, and C. So these are called secants, all right? S-E-C-A-N-T-S, a little bit strange word, secants or secants. Right? Secants extend beyond this circle, and we almost always put them in pairs, touching at a point that we form an angle, because now the relationships formed by this are really cool, and we love to give a lot of problems with these. So if A is 100 degrees, let's put this in as 100 degrees here, and that's the arc here. And if B is 50 degrees, that's this arc here. Right? Then we want to know what is C. So let's make this X. They're giving us the formula here for C. It's X equals A minus B, the larger arc minus the smaller arc. So let's just spell it out. Larger arc minus smaller arc divided by 2. Okay, so larger one minus the smaller one divided by 2 gives us the measure of this one, and that's why we love this so much, because this relationship is so cool. So with that note, let's do the math. X equals larger arc, 100 degrees. I'm going to leave the degree off for now just to do the math. Minus 50, a smaller arc, over 2. And that's it. That's going to give us X here. So 100 minus 50 is 50 divided by 2. X equals 25 degrees is the measure of this angle here. Now that we know the setup and that we're dealing with 2 secants, we might even try to go a little bit faster. Given the following secants and circle, what are the value of the missing angle? Same thing. Y in this case equals the larger arc, 200 minus the smaller arc, 50 divided by 2. 200 minus 50 is 150 divided by 2 is 75. So Y equals 75 degrees for the measure of this angle here. Given the following secants and circle, what is the value of the missing angle? Another one just like it. Y equals larger arc 160 minus 50 over 2. 160 minus 50 is 110, divided by 2 is 55 degrees. Given the following secants, now we're leaving the major arc undone. So let's try to map this out, right? We've got basically this angle 30 degrees is equal to the larger arc, let's call it x, minus the smaller arc, 90 degrees, over 2. I'm going to put a parentheses around this group here just to make equation solving more logical to my brain. I want to multiply both sides by 2 because that'll clear the 2 from the right, but what you do to one side you must do to the other in an equation because it must remain balanced. 2 times 30 is 60 now, and I'm left with x minus 90 over here. Since this is minus 90 on this side, I can add 90 to both sides, which is the reverse operation of the one I want to add. It's a minus, I add it. And what it does is minus 90 plus 90 is 0. This disappears from the right. And remember, when I say right and left, there's a center line down the equals. There's still an equals here. The x drops down as left on the right side, as remaining on the right side. And 60 plus 90 is 150 degrees. So this arc here must be 150. You could have done it by trial and error too, but that equation is far more fun to me to solve using equation solving methods. It's at least a 2-step there. All right, what else we got? Now they're telling us A is 120, there. B is 50, there. C is X. I'm going to call it X because I can write X is easier. I'm going to do X equals the larger arc, 120, minus the smaller arc, over 2. X equals 120 minus 50, which is 70 degrees, over 2. X equals 70 divided by 2 is 35 degrees. Now, the other type of problem that we love to use with two secants meeting at a point, forming a vertex here, we love the segment lengths. It turns out that the relationship in these segment lengths is the portion of the segment outside of the circle times the entire segment. In other words, if you see it right here, B times A plus B. So A plus B is the whole length, because A is the inside, B is the outside. So B, the outside portion, times the whole length is equal to D, which is the outside portion, times its whole length, C plus D. So now they're giving us dimensions of this to see if we can figure out this formula here, right? And they're telling us in this case it's B times A plus B equals D. I'm just writing this, rewriting what they wrote right here, C plus D. And I'm filling it in. B, they tell us, is 10. All right, but B is in two places. It's 10 there and 10 there. Okay, C is 4, right? So I have a 4 here. What else they give us? D is unknown. So if you don't mind, I'm going to put an X and an X for this. Okay. And I'm going to go back here. What is A? Did they give us A? Oh, I missed that. A is 2. So 2. So this problem, all we had to do was set up the overall equation. We didn't have to actually solve for X. We can, and we probably will in a later problem. But notice, let's just match it up. We've got 10 times 2 plus 10, 10 times 2 plus 10, and X times 4 plus X. And it's okay to say X plus 4 or 4 plus X. That doesn't matter. Anytime you're adding in a single step, you can reverse those two, and it's going to come out the same because of our properties of math. Well, now I'm sure they give us more problems with this whole situation. Some of them they might ask us to set up, some they might ask us to solve. So here's the equation again. It's the outside piece, 3 times the whole thing, 3 plus x, equals the outside piece times the whole thing, 2 plus 4. And I'm just going to write it 2 plus 4 yet. I'm not going to start to solve it. Don't get ahead of yourself. Don't go ahead and write in 6 yet. Just keep it this way, because they're really asking us just to set it up. 3 times 3 plus x, 2 times 2 plus 4. And let's do a few more of these for you to practice. Given the following sequence and circle, set up, allowing to find the missing value. Here's the missing value. Let's take the outside portion of the secant times the whole bit, 2 plus x, equals the outside portion, 3, times the whole segment, which is 3 plus 8. And I could have said 8 plus 3 does not matter. So 3 times 3 plus 8 is the right. The left is 2 times 2 plus x, or x plus 2. Just getting me to practice the relationship here. All right, given the following secants and circle, find the missing value. Same thing. Ooh, look at this, an x and a 2x. Don't panic. 3 times 3 plus 4. So the outside piece of the segment times the whole. 3 plus 4. The outside piece equals x times the whole thing. It's got to be x plus 2x. And that's it. They're just asking us to set it up. 3 times 3 plus 4. So they're not even testing us on equation solving here. They're just testing us on setting up the relationship, right? Let me circle that. Now they're giving us dimensions and saying fill it out. They're saying A is unknown. So let's call this make this my lovable x. Let's make B 10. This equals 10. C is 4. And D is 15. And let's run through the routine. Outside piece 10 times total, x plus 10, equals outside piece 15 times total, 15 plus 4. And there we go. 15 times 15 plus 4, check. And it doesn't matter if you reverse sides of equations. Remember, equation can be flipped. You just rotate the whole thing, including the sign rotates if it's an inequality. 10 times x plus 10. So this is secant practice and dealing with the relationship of the segments and the arcs of secants. Here's the exact title. Make sure and match it up with the table of contents on creatormath.com under the geometry tab.